In this video, we're going to take a look at how to perform a hypothesis test for a population proportion. So let's check out this example. It says, a clothing store claims that only 12% of their online orders are returned. A quality control manager suspects the return rate is actually higher. To test this, the manager takes a random sample of 500 orders and finds that 75 were returned. Perform a hypothesis test to determine if the true percentage of orders that are returned is 12%. So to perform this type of hypothesis test, the first step is we're going to state our null and alternative hypotheses. So the null hypothesis is that the true population proportion, denoted as P, is equal to 12%, or as a decimal that's 0.12. So you can think of this as the default belief, or the current widely accepted belief. So the store claims that 12% of their online orders are returned. But this manager comes along and they think the true population proportion or percentage is greater than 12%. So the alternative hypothesis is that P is greater than 0.12. Now step 2 of this hypothesis test is we need to set the significance level. So for this hypothesis test, we're going to choose a significance level of alpha equals 0.05. Now, other common choices are 0.1 or 0.01, but for this example, we're going to use 0.05. Now, step 3 of our hypothesis test will be calculating the test statistic. So for a hypothesis test for a population proportion, our test statistic is going to be a z-test statistic that uses this formula right here. We take the sample proportion, denoted as p hat, minus p, the currently accepted population proportion, divided by the square root of p times 1 minus p divided by n. Now in this example, the sample proportion, p hat, that's calculated as the number of orders that were returned in our sample out of the total number of orders. So that's going to be 75 out of 500. And if you punch that into a calculator, that comes out to 0.15. So in other words, 15% of the orders from our sample were returned. So the value that we'll use for p hat in this formula is 0.15. So we're going to take that sample proportion and then subtract the population proportion, which currently is accepted as a value of 0.12 or 12%. We then divide that by p times 1 minus p, so 0.12 times 1 minus 0.12, and we divide that by the sample size that we used, n. And our sample size, again, was 500 online orders. So the value for n is 500. So when you punch all of this into a calculator, this comes out to 2.06. This is known as our z-test statistic. Now what we need to do is calculate the p-value associated with this test statistic. So to do that, let's pull up a z-table. So here is our z-table. So let's look up the value 2.06 in this table. So first we'll look up 2.0 along the left-hand column. So that's right here. And then we need to look up 0.06 along the top row. So that's right here. And then we'll draw a line, a horizontal line, and a vertical line, and see where these values intersect. And we can see they intersect at 0.98030. Now, what's important to understand is that the values inside of this z-table tell us the percentage of values that fall to the left of a particular z-score in a standard normal distribution. So if we think about a standard normal distribution that looks something like this, where the mean is right in the middle and that value is 0, for a z-score of 2.06, that falls somewhere out here. So let's say that's 2.06. What this value in the table is telling us is that about 98% of the distribution falls to the left of that z-score. So to the left of this z-score, that area is 0.98030. Now recall, for this hypothesis test, our alternative hypothesis is that the proportion is greater than 0.12. So whenever you see a greater than symbol in your alternative hypothesis, that means when you look up the p-value, what you really want to find is this area that's greater than your z-test statistic. So to find this area, we need to do 1 minus 0.98030. And that comes out to 0.0197. So this is the p-value that corresponds to our z-test statistic. So let's go ahead and write that down. So step 4 of our hypothesis test was finding the p-value, which we just found is 0.0197. The very last step is we need to now compare this p-value to our significance level. If the p-value is less than our significance level, then we will reject the null hypothesis. So we can see that indeed our p-value 0.0197 is less than 0.05, so we will reject the null hypothesis. So as our last step, we'll say since the p-value is less than 0.05, we reject the null hypothesis. So what we can say is that we have sufficient evidence from our data to reject the null hypothesis and conclude that the true proportion of online orders that are returned is greater than 12%. So that is the general 5-step process that you can use to perform a hypothesis test for a population proportion.